Hello friends, welcome to the third session of Matrices. In today's session, we're going to deal with solving of simple equations using matrices. My name is Srinivas and I am the Chief Mentor of Career Launcher Bangalore. I'm also an alumnus of IIM Indore and IIT Dhanbad. Alright, so let's start off with what we learned in the last class as a recap. In the last class, we have seen few elementary row and column operations. I hope all of you remember what happened there. We have seen these three elementary row and column operations, interchanging of rows and columns, multiplication of a row or a column with a non-zero number, addition of rows or addition of columns. We have seen these basic things in the last class. We also discussed that these operations can be used in solving a simple equation. So how are these actually going to be useful? That is what we're going to see in today's class. Now, I want to give you a hint on how can a matrix help you solve simple equations. The hint is, look at this matrix. Do you get any idea? Do you get any idea by looking at this matrix? If I say this is a matrix written for two equations, which means this is your x coefficient, this is your y coefficient, and this is your constant, right? So what is the idea that you get if I give you this as hint? Take a moment and try to understand. So what does anything light in your head? The idea is if you can convert a given equation or a given matrix into a 1001 format. Let me explain with an example of what I mean. Let us say I have 2x plus 3y equal to 34. 3x minus 6y equal to minus 33. This is what I have here. This is the equation that I have, or the matrix that I formed from these two equations. Somehow, if I can convert this into this matrix using row and column operations, what will my equations become? My equations will become x plus 0 equal to a and 0 plus y equal to b. Straight away you will get x equal to a and y equal to b. That is the idea behind conversion of matrix A into matrix B, right? Conversion of first matrix into the second matrix. But to convert this matrix, we are going to use our basic row and column operations. I hope it's clear to all of you that when you convert this new matrix, straight away gives you this one. Basically is for x, which means whatever you get here straight away becomes x equal to a. Whatever you get here straight away becomes x equal to b. Right? So let's take a look on how do we convert this. That is what we're going to deal with now. Okay, so this is the example that I gave you. Somehow I want to convert this into this format. So let us see how will I get. So actually I already did the conversion on a rough paper, obviously. And I found that x will be 5 and y will be 8. Now I'm going to show the procedure to convert your matrix which is given into the format of 1001, and the third column will be your answer, right? So now let's start with this. The first step, if you look at it, will be 2, 3, 34, 3, minus 6, minus 33. Now what I want you to do is I want 1 here and I want 0 here. You can clearly observe that if you multiply R1 with 2 times R1, so basically you are multiplying the entire row with 2 times of R1, that is number 2. Then if you add R2 to it, see what happens. So what happens here? You will get 2 into 2, because 2 gets multiplied by 2, plus 3. Basically, the 2 here is getting multiplied by 2 and 3 is getting added. Similarly, 3 gets multiplied by 2 and plus minus 6. So that is net of negative 6. Then similarly, you have 34 into 2 minus 33. The second row remains the same. 3 minus 6 minus 33. This will not change. So what happens here? 4 plus 3 is 7. 0. 34 into 2. 34 into 2 is 68. Okay, let me write it here. 68 minus 33. What is 68 minus 33? 55. Right? Sorry, my bad. It's not 55. It's 35. And this will remain 3 minus 6 minus 33. Right? Now, we have it in the form of 70. But what do I need? I need it in the form of 105 or 10. Basically, if I want this to become 1, I will next do R1 as R1 by 7. Right? So what happens if I do this? I will get 7 by 7, which is 1, 0 by 7, which is 0, 35 by 7, which is 5. The other numbers remain the same. So here, straight away, the first equation becomes x plus 0 into y equal to 5. Or straight away, you get x equal to 5. The moment you get x equal to 5, you don't have to waste your time in trying to solve for the y. From here, you can put x equal to 5 in the given equation and you can get your y. In fact, we can also try to get this in the form of 0 and 1. Let us see how do you do that. So right now we have this. Let me erase everything and only write what I need. Right? So 105, 3 minus 6 minus 33. So 105, 3 minus 6 minus 33. Now, to be very honest, you don't need to solve this further because you already got x, so you can get your y. But because we are doing this to understand the process, let me continue this forward. Now, what will I do? I will now divide. So I will now divide R2 by 3 because I want this to become 0. So first I will make it as 1. So what will I get? 105. Now R2 by 3 makes it 3 by 3 is 1. Minus 6 by 3 gives you minus 2. Minus 33 by 3 gives you minus 11. Now I want this 1 to become 0. This 1 to become 0. So what will I do? I will do R2 minus R1, which is your R2. R2, I will subtract R2 minus R1. So I will have 105 without change. Now next, 1 minus 1, which is 0. First R2 should come, keep in mind. So minus 2 minus 0, minus 2. Minus 11 minus 5, which is minus 16. Now the next job will be to convert this into 1. So if I want this to become 1, I will take it as R2 R2 by minus 2. So what do I get from here? I get 105. 0 by minus 2 is 0. Minus 2 by minus 2 is 1. Minus 16 by minus 2 is 8. So I got it in the form of 1001, which means 5 is x, 8 is y. Now you might be thinking, why are we doing in such an elaborate process? Remember, if you have a two simple variable equations, guys, do not use matrices. You can straight away use your simple equation solving method. But why did we learn this then? This process we are going to use in finding identity matrices in the future classes. So this process of finding or converting 1 0 0 0 1 0 0 0 1 for a 3 by 3 matrix, that is if the fourth column then becomes your, so if you're dealing with 3 variables, right? X, Y, Z. Then you will be having a 4-column equation, right? You'll have something like 2x plus 3y minus 4z equal to 10. So you'll have 2, 3, minus 4 and 10. So you'll have 4 columns like this. So when you convert this into this format, the 4th column becomes your x, y and z directly. This whatever comes here, whatever comes here, whatever comes here will become your x, y and z. Right? So this process is the same. You will try to make it into ones, zeros and ones. But don't use it to solve simple equations. My recommendation is know the method. But if you want to solve simple equations, use what you have been doing till now. Solving for x and y. But the best possible use of this comes when you're supposed to find inverse of a matrix, or when you're supposed to find identities or convert a matrix into the identity form, which we will see in the subsequent classes. So that's all for the class today, at least for this session. Have a good day or good night, depending upon when you're watching this video. Thank you, guys.